All right, hey, welcome to MS101, Lesson 04 on Basic Map Reading. My name is Captain Silver Beatty. I'm an APMS at the University of Montana Grizzly Battalion, and I'm going to be leading you through this lesson today. Now, before we even begin, there's a QR code right there in front of you. Feel free to scan that. It's going to take you to a website version of this exact same presentation, but it also has embedded and clickable links and other resources that you can get to that might give you just a little bit more in-depth stuff as far as understanding this basic map reading concept. Now, this is a very inclusive presentation. It's going to be a little long. We'll go into some details about things. And if you do have this pulled up, even while you're listening to this on YouTube, if you can pull this up on your phone and just follow along, maybe click some of those links as we're going, it might make it a little bit more easy to engage with the material that we're going to talk about today. So it's a very foundational class on basic map stuff, kind of the next step to getting into land navigation. So with that, there's a lot of information. Might be a good idea for you to have a piece of paper and a pen or pencil so you can jot some notes down as we go along. Feel free to pause that video as we go so you can get those notes pulled in, or have a Word doc open on the side. Whatever's easiest for you, however you take your notes. But there is, again, a lot of information here that you're not going to be able to just internalize by listening for the next little bit of this video. So with that, as always with a lot of my videos, you're going to have a slide here that if you have that QR code and you have that lesson pulled up on your phone, you'd actually be able to click on these different links. I'm not going to show them to you right now, but they do link to some other helpful videos, including two that we're actually going to watch during this presentation. As well as that read ahead that'll give you a lot of information about basic map reading, as well as a little bit of information about land navigation. And the Fort Knox map digital version is actually linked to this presentation as well. So it might be easy if you want to scroll on back to the beginning of this video, it might be worth your time to pull it up on your phone, copy that link, email it to yourself, pull it up on a computer, so you can go through and actually have that Fort Knox map attached or open while we're going through some of this stuff. If anything, maybe your cadre member gave you a map of Fort Knox, like a fold-out map. It'll be pretty big. That's even better because a lot of the stuff we're going to do towards the end of this, as well as the land navigation class, will actually be user-friendly to have that map in front of you. Because there's a lot of moving pieces to this that's just, let's face it, impossible for me to teach you through a screen on YouTube. So again, take those steps, make yourself better. Go grab a map, pause this for now if you don't have to watch it, go get that map in front of you, or figure out a way to click on that Fort Knox map so you can have it pulled up. All right, with that, let's get into this. So our learning objectives for this lesson, by the end of it, I want you to be able to identify the marginal information on a map, the topographic symbols, and all the colors on that map. Then I want you to be able to classify the 5 major, 3 minor, and 2 supplemental features that are found on a military map. And then at the end, we're going to learn how to locate some grid coordinates. Now that's really the base step of getting into land navigation. All right, so when it comes to that marginal information, again, like I said, if you're able to click on this, pull it up somewhere else, it's going to be easier for you to scroll through and look at these things, or have that big Fort Knox map folded out in front of you. It's going to help you be able to go through the next little bit of marginal information, which by that I just mean the additional information outside of that topographic, obvious land. It's all that stuff on the bottom and some of this stuff up there on top. So let's go through this together. Pause here if you need to pull that map out. Otherwise, let's move on. So our marginal information, we have a lot of bits and pieces that go into a map. And I've done screenshots of the actual Fort Knox map to give you the examples of exactly what we're talking about. So we've got our sheet name, which is on this particular one, Fort Knox Military Installation Map. That's the name of this map. The sheet number is typically a number on a lot of maps. On this one, it's FTKNOXSPEC, or Foxtrot Tango Kilo November Oscar X-Ray Sierra Papa Echo Charlie, Fort Knox SPEC, right? And then we have our adjoining map sheets diagram. So it's also going to be on your map there. I'll show you on the next slide exactly where you'd find it. But this is just to show you what other map numbers or names are surrounding this, so that you could actually take multiple maps and connect them together to get an even bigger picture of the area. So you can see there that the adjoining map sheets diagram shows multiple 8 other maps that connect to this specific map. So when you actually have that all folded out, that's where you can find that information. So the sheet name is on top there in the center, the sheet number is in the far right corner on top, and the adjoining map sheets diagram is over there on the far right towards the bottom. Let's talk more things here. So we've got what we call the declination diagram. Now when it comes to land nav, and you're going to find about doing azimuths and azimuth conversion, this is actually a super important thing to be able to find on every single map. It does look different. No matter what your map is, that declination diagram changes. And I'll explain why either in this lesson or more so in the land navigation lesson. Now we also have our special notes. This is just additional stuff that makes this map different or stuff that you might need to know as you're reading through it. And then you have your grid reference box that shows you your left and right limits of what the grids are in this particular map. So if we have that all folded out, on this map, you're going to find the declination diagram just right of center there on the bottom. Your grid reference box is directly center there on the bottom, and your special notes are off to the right on the bottom as well. So when we come to scales, this is another very important thing because we use this to find our distance between points, distance between different things on the map, right? And it also shows us our contour interval notes. So what those contour interval lines, what their elevation is measured in, as well as how far apart in real distance those contour interval lines are showing. So on this map, you're looking at contour intervals of 10 meters. So that means for every contour line that you see, it's showing a difference of 10 meters of elevation. You've also got your scale there on top, and your bar scales are going to be working in distances. All of this information on this map is directly there in the center, right underneath the actual land portion of the map itself. Now we also have things called the map agency, who produced this map, who's kind of the overarching overseer of this map. And you have your legend. Now legends are going to be different on every map as well. So it's important to really pay attention to your vegetation, relief features, any water or drainage information, as well as how to see the difference between your boundaries, maybe some of the roads, what colors are they, what do the colors designate, and some of your populated places. So legends are important. Always check those out when you look at a map. See what's different from map to map because some of them do change quite a bit. On this map, your map agency is there on the bottom left with the legend directly underneath it. Now, military map colors. These are pretty cut and dry. They're pretty basic, and a lot of them are kind of common sense, right? Now, on our military maps, every military map should follow this color designation. So anything that's in black is a man-made feature. Common sense would tell us that anything in blue is going to be a water feature. Brown designates relief features and elevation on older or even red light readable maps. Green, again common sense, shows your vegetation. So your trees, your brush, your just different foliage that might be found in that area. Red is going to designate any man-made features, and that's used on older maps because those can't be seen with a red lens that you would find on a headlamp. So red-brown is going to show your cultural features and maybe some non-surveyed spot elevations that are up there. And then there's always other colors. Now, occasionally these other colors can be used to show like your special information, and if used, it's going to be noted in your marginal information, either on your legend or in your special notes. All right, so let's move into terrain features. So like I said in the beginning, you're going to be able to identify the 5 major, 3 minor, and 2 supplemental terrain features that we use within the military and the U.S. Army itself. So our major terrain features, a way to remember these are they have major impacts on an operation. They're usually larger, they stand alone, and the way to remember this is through a mnemonic that I love, that I learned back in the mid-2000s when I put the uniform on for the first time. I learned Hidden Valley Ranch Salad Dressing. And that is what I still use to this day to remember my major features. And those include hills, which also includes mountains, valleys, ridges of a mountain or a hill, Saddles, depressions, all of that, they're all considered major terrain features. Now here you have your minor features. These ones are usually found as part of a major feature. So the three that we have here are draws, spurs, and cliffs. And I'll show you what these look like, but a draw, think of and remember it's drawing water in. Spurs, think of like cowboy spurs, like up here in Missoula, Montana, we got spurs on our boots, right? Spurs kind of jut out and away from our boots. So spurs are kind of big jut outs from a hill or a mountain. And then you got your cliff. Everybody knows what a cliff looks like, but it's a very quick and dramatic drop off of something larger, right? And I'll show you what that looks like as far as how it's designated on a map. Now, supplemental features, these are man-made. So we have cuts and fills. And when we think of cuts, cuts are cutting into a mountain maybe to create a road, create space to put in a railroad. That's what cuts are for. Fills are the exact opposite. We're filling with dirt. And you've probably heard of the term fill dirt, right? So fills are filling up an area or boosting it up, maybe making it stronger for things like bridges or overpasses. So fills are used to kind of push that up and even out the terrain. Again, supplementals are man-made. Minors are usually part of a major terrain feature, and your major features are larger and usually have a pretty big effect on operational movements. All right, so we're going to go piece by piece. I'm going to show you on all of these. On the left side is going to be an in real life version, and on the right side is going to show you how it should look on a military map. So when we're talking ridges, this is a sloping line of high ground. The center line of a ridge normally has low ground in 3 different directions and high ground in one direction with varying speeds of that slope. If a ridge is crossed at right angles, a soldier climbs steeply to the crest and then descends steeply to the base. And contour lines forming a ridge tend to either be U-shaped or even V-shaped. And the closed end of the contour line points away from that high ground. So you can see here, we've got a ridge line here. This side right here probably looks identical to the other side, right? A steep line of elevation on the left and on the right. And here you've got your hilltop, and coming down this way is your ridge line. And these are going to be pretty similar on each side of this line here. And you can see these ones are U-shaped on the contour lines. Now a ridge line is just basically that happening over and over and over again. So you can see a real quality image version here. But think of like a mountain ridge or a ridge line, that silhouette that you see. This side here probably looks pretty identical to the other side where it's very steep and sloping. And on a map, you're going to see multiple hilltops, just like this, with those same U-shaped contour lines coming off, showing that degree of elevation change. So this is really just a line of high ground, usually with changes in elevation along the top and low ground on all sides. And this is, a total of 10 natural or man-made terrain features are classified. Right, so what's a hill? Well, we know what a hill is, right? It's a high area of ground. So from a hilltop, the ground slopes down in all directions. A hill is shown on a map, as you can see there, with contour lines kind of forming concentric circles. The smallest closed circle is the actual hilltop. So the X is where the hilltop is. And then all of these contour lines are showing a drop in elevation, which we'll talk more about in just a moment. But this is dropping off. So that's how those contour lines are used. So again, hilltop here, and everything is sloping down in all directions. Now saddles, these are kind of a dip or a low point between 2 areas of higher ground. So it's not necessarily the lower ground between 2 hilltops, it's just simply a dip or a break along like a level ridge crest. So if you're in a saddle, there's high ground in 2 opposite directions and lower ground going the other 2 directions. And it's usually seen as kind of like an hourglass shape. So here you've got a hilltop and a hilltop with a saddle right in the middle. Here again, you've got a hilltop here and a hilltop here, and the saddle is this drop in elevation where if you're standing here, you've got elevation going up on 2 sides, and then you've got elevation going down on the other 2 sides. Now, valley, it's going to be a little bit different. So this is going to be more of a stretched out groove in the land, formed by typically streams or rivers, right? So when we look at valleys, a lot of times when you see them on maps, you can actually designate that it's a valley or come to the conclusion it's a valley because there's either seasonal water or regular water being shown there. So you can see here on this map, this is the valley area, and you can see this rainwater or some sort of seasonal water coming through. Now it begins with high ground on three sides and usually has some sort of that water running through it. So if you're standing in a valley, three directions give you high ground while the fourth direction is going lower. Depending upon the size of that valley and where you're standing, it might not actually be obvious that there's high ground in the third direction, but water flows from higher to lower, right? That's how we understand gravity. So the contour lines on a map forming a valley are either U-shaped or V-shaped. And to determine the direction the water is flowing, you got to use those contour lines to see where the elevation is going down versus up. Now the closed end of the contour line, whether it's a U or a V, always points upstream or toward high ground. So here, this is the closed end of a contour line, right? It comes to a close right up here. So it's pointing upstream, which means this water is flowing down this way. Now the depression, it's our last major feature here. A depression you can imagine as being like a sinkhole, or it looks like a crater. So it's a low point in the ground, kind of described as an area of low ground surrounded by higher ground in all directions. So almost the opposite of a hilltop, right? Only depressions that are equal to or greater than the actual contour interval is even shown on a map. So depressions are represented actually by closed contour lines that have tick marks, and those tick marks are always pointing towards low ground. And remember that because this isn't the only feature that's shown on a map with tick marks. So in this particular one, this depression here, you can see this, the hole in the ground, some sort of sinkhole or something, and the tick marks pointing in towards that X mean that that's the direction that the elevation is going. So it's really showing that it's kind of the opposite of a hill. So now we'll move into our not major, but our minor terrain features. So a draw is where a stream course has been less developed. It's not quite as big as a valley. So there's essentially no level ground and no or very little maneuver room within the confines. So in a draw, the ground slopes upward in three directions, downward in the other direction, and it could kind of be considered as the initial formation of a valley depending on the size. But the contour lines depicting a draw are either U-shaped or V-shaped, and they're always pointing towards higher ground. So in this one, again, you can tell that this is a draw because the contour lines are forming a U or a V shape right here, and they're pointing up towards higher ground. So the draw is coming down this way, and you can see there's water attached in this one as well. So this draw is coming off of a hilltop up here, coming down, there's water, and it's the kind of the inside. It's drawing water into it. Like I said at the beginning, the opposite of a draw is going to be a spur. And we have the exact same picture here where we just saw a draw right here, and now we see a spur, so it's that area kind of jutting out. So this is a very short, continuous sloping line of higher ground, normally coming out from the side of a ridge. The spur is usually formed by two roughly parallel streams cutting draws down the side. So the ground slopes down in three directions and up in one, and the contour lines in the map with the U or the V are usually pointing away from high ground. So you can see in this one, these U's are going the opposite direction. So we've got the draws with the U's going this way up towards high ground, and then we have the spur going down away from the high ground. So that's how you can depict the two, is that they're just opposites of each other. Draws create spurs. So spurs are created by two draws or two streams of water kind of eroding that land out of the way. Now a cliff, like I said, everybody kind of knows what a cliff looks like, right? A cliff is going to be a vertical or pretty much near vertical feature that's a very abrupt change. So when a slope is so steep that the contour lines converge and they can't show the difference in elevation, that's when you're going to see a cliff. With that, you're going to see these tick marks again, and they're going to point towards low ground. So cliffs are usually shown by that one contour line, a few that come really close together, and then they're touching, And in this instance, you start seeing the tick lines that are designating that this area is a just straight down cliff. So this right here is what it would look like on a map. We already know what a cliff looks like. Every rock climber's dream right here. All right, now we'll get into our supplemental features, which is that, again, these are man-made. So a cut in the ground to create some sort of a road or railroad maybe. It's used to form like a level bed. So cuts are shown on a map when they're at least 10 feet high, and they're drawn with that contour line along the cut line. So this contour line then extends the length of the cut and has the tick marks that point in to the road bed. So if the map scale permits, it'll show this level of detail here. You can see here, this is a road, looks like I-5 or Highway 5 going this way. The cut is this length, so that's the length of area that they actually had to cut into something. You can actually tell the sloping contour line that used to be here. This used to be one feature. Cut into it, the tick marks are going towards the railroad. Now fill is the exact opposite. Also a man-made feature. It's a result from filling a lower area to make it level for, again, a railroad or a road. These fills are shown on a map when they're at least 10 feet high, just like cuts, and they're drawn with a contour line along the same thing, the fill line. So it's going to show the length of how long that fill was actually created. So again, it's going to extend the length of that filled area, has tick marks that point towards lower ground. So if the map actually shows it, the length of the fill tick marks are drawn to scale and extend from the baseline of the fill symbol. So you've got a fill right here again, you've got I-5. So here's our cut. This was the cut in that road. And then they had to build it up to make it level over here, so they had to take basically all of this dirt, and I'm assuming if they were smart, they just rolled it right down here and used it to build this up, to bring this up, because you can see there's likely a stream or some sort of water feature here where they had to build this bridge over the top. So they had to build this up, this area right here where this X is, that's the fill dirt that creates that fill. Okay, so that was all of your terrain features. Now we're going to work a little bit more towards using grid coordinates, azimuths, things like that. They're going to play into your land navigation skills. Now this lesson doesn't touch on land navigation as much. There's a whole other video for that, but we're going to start with learning about our protractor. So the interesting thing about our protractor is it's actually a circle, even though it's shaped like a square. Now, if you understand math, even the basics of math, we know that there's 360 degrees in a circle. And if you look on the inside of your protractor here, you can see the degree designations. So we've got degrees on the inside, mils on the outside, and then we've got our index. So our index point is right here. On most protractors, there's actually a hole at that exact point right there. Some of them don't have that hole, but that's where your index mark is. And then we have this up-down vertical line is called your baseline. And then you have multiple triangles, depending on what your protractor looks like. You should have 3 different scales or different triangles that work with different scales on a map. So for this one, all 3 of the triangles where the points like this are 0 and 0, 0, 0, 0, 0, that's called your 0, 0 point. And that's important to remember for when you're actually starting to plot grids on a map. Also remember, for the most part, when it comes to land nav, you're always going to use degrees. We don't use mils. This is for separate, a separate type of navigation, separate type of land and operation. For now, always focus on these degrees on the inside, which you can see start at 0 and they come all the way to 359. And that 0 right there is also 360. So how do we determine grid coordinates? Well, it's step by step, and it's very important that you remember the exact steps to do this so that you don't end up on the wrong part of your map. So first, you want to pick the correct scale on the protractor. Now, like I said, there's 3 separate triangles on that one. You want it to fit exactly within the grid square. So if you're looking at your grid points or your grid lines on a map, the 10 on each protractor, or the 1,000 here, This last mark right here should line perfectly up with a grid line. And this last mark right here should line perfectly up with a horizontal grid line. So you want to make sure that whatever triangle you need to use, you can figure out by lining this up and lining this up. And if it fits perfectly in the square, you got the right one. Then you want to place the horizontal scale on the grid line with the 0, 0 point at the lower left-hand corner of the grid square. Lower left hand. So when you figure out if it fits, you're putting that 0, 0 mark in the lower right hand. When we start actually plotting grid points, we actually move that all the way over to the left, and we start with the 0, 0 and we're reading to the right. So once you're there, you're going to then slide that scale right until the vertical scale intersects the center of your plot point. And don't worry, I know this is hard to take in while I'm just talking it to you instead of showing you, but I'm going to show you a video that points it out. Every time you're plotting points or determining points, you're always going to read right, stay horizontal, and then you read up. So you always go horizontal and then up. So again, if you're into math, you've got your x-axis is usually your horizontal, your y-axis is usually your vertical, and we know that in the English alphabet, x comes before y, so you should always read horizontal and then read vertical. So we've got our 0, 0 point right here. We said you're going to place it. We're actually trying to determine this point. So you figured out that you fit in this box. This is the scale that you're using. You can see on your protractor we're using this top left one. You're going to place your 0, 0 point now in the bottom left. So we've got this grid square we're using. 0, 0 point goes right here in the bottom left. This is to determine this point right here. Now we know that we are in box 7, 8, because we're using our grid lines going horizontal. We're in box 7, 8, because this is our line over here, and we're in 0, 0 going up. It's this one, we're in the 0, 0 box. So our 4-point digit right now, our 4-digit point, excuse me, is 7, 8, 0, 0. Now if I were to say find 7, 8, 0, 0, you're going to look at this map and you're going to find the 78. Okay, we know we're to the right of the 78. And then 0, 0, you're going to find that line, and we know we're at the box above the 0, 0. So this right here is box 7, 8, 0, 0. Now as in another example here, this box would be 7, 6, 9, 9. We've got our 9, 9 right here, and we've got 7, 6 right here. We're going to go over to 7, 6, all the way up, and then go up to 9, 9, and that would be the 7, 6, 9, 9 box. This one over here, we go over and we see that we're in the 7, 9 box, and 9, 8 is this line horizontally, so this box right here would be 7, 9, 9, 8. We're going to go back and we're just focused on this point right here where we're in 7, 8, 0, 0. So that's your 4-digit grid coordinate. To figure that out, like I said, you're going to identify the square identification letters in your grid reference box. You're going to read right to the last east-west grid line depicted before your point. So that would be this one, right? This is the last one before your point. And then you're going to read up to the last north-south grid depicted below or before your point. So 0, 0 is the last one before our point. Therefore, box 7, 8, 0, 0. Also a 4-digit grid. This will get you within 1,000 meters of your point. So if I said go to 7, 8, 0, 0, you will be within 1,000 meters of your point. Think of that as 10 football fields. That's a pretty big space to be within to find this point. So we're going to narrow that down a little bit to a 6-digit. And once again, we're going to take that and we're getting right here into the 7, 8, 0, 0 box, but we're going to try to get just a little bit closer. So remember when they said take that box, you're going to, or your protractor and your scale, you're going to start in this bottom left-hand corner and you're going to slide it to the right until this line hits that point. Then you're going to read right here. So whatever this looks like on the horizontal side, so it looks like 5, 0, it's right on the 5 there. That's your first horizontal number. Then you're going to just leave it right there and look up. And where does that X intersect on your vertical scale? Looks like it's right around the 3. So that means your vertical number then becomes 3, and your 6-digit grid becomes 785003. Now you got to remember to keep that 5 with the other horizontal numbers and that 3 with the other vertical numbers. So you actually split these up, and you're now understanding that you're in box 7800 over 5 and up 3. Now, I could talk through the 8-digit grid coordinates. If you can see how we're going, we're just getting closer and closer. I'm actually going to play this video because it's very informative and explains it even better than I can because I'm just talking to you through the screen. So watch this video, take some notes, and this is how you're going to plot an 8-digit grid coordinate.
Hey, if you're looking for help,
plot a grid coordinate, you came to the right place. So let's get to this. And if you enjoy the content of the video, make sure you hit the like and the subscribe button, hit that notification bell so you can stay up to date. And in this video, we'll be using a military protractor, a mechanical pencil, and a map. All right, let's do this. All right, so I got my map, I got my protractor, and a lime green mechanical pencil. Now you don't have to use a lime green one, you can use any one that you got, but you just want to make sure that the tip is as fine as you can. So why do I want to use a fine tip mechanical pencil over something that I've sharpened or a pen? Now I'm going to zoom in a little bit closer here, and let's look. I'm just going to take a small pen. I'm going to offend the map gods that are out there, and I'm going to make a small mark right there with my pen. There we go. You see that? And then if I take my protractor and I measure it, I can see that that point is almost 50 meters. Almost 50 meters, man. How ridiculously crazy is that? And if I make that same error here and I make the same error to where I'm going to, not only is my distance going to be inaccurate, but my direction is going to be inaccurate. Everything's going to be inaccurate. And I want to try to eliminate all the inaccuracies I can as I'm putting everything on a map. So I want everything as perfect as I can on a map. So do yourself a favor, double check everything. If you need to, measure twice, cut once, measure 3 times if you need to. Just make sure that what you put on the map is correct. All right.
So what he's talking about there in the pen versus pencil thing is basically just explaining that a pen, 1, you should never write on a map with a pen, but 2, the tip of a pen is so thick that when you plot a point, it could be up to 50 meters wide. That point that you're putting on a map could be on scale 50 meters wide. And if you're plotting multiple points that way, your distance, direction, everything could be way off. So you want to use the thinnest line that you can, or the thinnest pinpoint on a pencil. So recommend that you have a very thin mechanical pencil, the smallest, finest that you can find, and use that as your land nav and plot pointing pencil.
So let's plot our first point. The first point that we're going to look at is 24300236. So I read my maps to the right and up. So I read over to 24 and then up to 02. So I know I'm going to be plotting somewhere in this grid square right here. Now 1,000 meters is not accurate enough for anything. Even if somebody told me to go to the body of water in 2402, which we can see right here, it's not accurate enough, because if I'm coming from another location, I may assume that I'm in 2402, but I'm actually not. The next level of accuracy is going to be a 6-digit, and that's going to get me to within 100 meters. And of course, 100 meters, man, still, again, it's just over 300 feet. And if I'm looking for a specific major terrain feature, a 6-digit might be close enough, but I want to try to get a little bit closer. So now I'm going to be looking for an 8-digit, and an 8-digit is going to get me down to 10 meters, or just around 33 feet. So I'm going to take my protractor, I'm going to set it down on the bottom left-hand corner of 2402. 2402. There's my 00 mark right there. And I'm going to slide my protractor to the right until the 3 is right in line with the grid line right here of 24. And now I'm ready to read up to 36. So I'm gonna read up to 3, and since it's a 6, since that last digit is a 6, it's gonna be just above this hash mark right here. So I can see that it's right at the corner of this triangle right there, right? So when you're ready to mark you want to make sure that you slide your protractor over to the left a little bit and then make your mark. And then you put your protractor back down and then slide back over to 3-0 and read up to 3-6. Now my mark is a little off, so that's not a big deal. So we're gonna erase that. And I'm gonna put it to where I think it is right there. And again, this is why you measure twice and cut once. Read back over to 3-0 and up to 3-6. So I want to make sure that that lead mark from my pencil is directly underneath the black line on my protractor. So I'm just going to raise it up and then lower it back down to make sure that it's good to go. And once you got that, you're set. Now, if you need to, right, just take and draw a circle around it. If you draw a circle there, it'll help you come back and find it later on down the road if you need to. All right, so the next one that we're going to plot is going to be 24950293. So again, I'm going to put my protractor back down on 2402, and I'm going to slide my protractor to the right all the way out to 95. And then I'm going to read up to 93. So the 93 is going to be in between the 9 and the hash mark in between the 9 and the 10, right? So again, I'm going to slide my protractor over to the right. Tiniest mark there. Set my protractor back down. 9-5, got it there. And then 9-3. Man, that booger's right on the mark. It's almost like I've done this a couple times. And I'm gonna set a mark there. Now I've got 2 points here. And the last, I'm gonna leave you with one more thing here, other than just plotting the points, and it's gonna be determining an azimuth. So if I set my protractor down and I got one edge where I'm starting from and one edge where I'm going, I can put a mark out here, and I'm gonna put it way out here because I'm not gonna be moving out here. I'm moving in this grid square, so I don't care if I get a little pencil mark way out here, right? And then I'll take my protractor. The center of my protractor has a little hole in it right here, right? So I'm gonna put that right over where I'm starting from, and I'm gonna ensure that these black lines are perpendicular and parallel to the grid lines on my map. I'm gonna take a piece of paper and I'm gonna line it from where I'm starting from off over going to where I'm going. I got my black line there, and I can see that that is like right at 49 degrees. And of course, that is a grid azimuth. So you always want to make sure that you understand that. Now, if you're ready to use a compass, you just convert using your GM angle that you can find on your map, and you're ready to set out. All right, everybody, so there you have it. We went through the process of how to plot it.
All right, so there's your 8-digit grid coordinate. Like I said, he was able to explain that a little bit better than I could if I were to try to talk you through it. So he was able to actually show you. And here, it's just bringing it down, like he said, within 10 meters. So we're getting closer and closer. So always remember that a 4-digit grid gets you within 1,000, a 6-digit grid gets you within 100, and an 8-digit grid gets you within 10 meters of your target. So with this being 5-3, you can see that they slid this protractor over so that this vertical line is in between the 5 and the 5-5. That hash mark is 5-5. It's right in between. And then when you move up, you can see that it's right above the 3 mark at 3-2. And that is your point right there. So this, going from that very first slide to where we're kind of looking for our target point here, this is what your 8-digit grid is going to end up with. So if you were to mark down or get a digit of 7, 8, 5, 3, 0, 0, 3, 2, you will be within 10 meters of this mark right here that you're looking for. So that's how you plot those grid points. So with the practical exercise, what I'd like you to do is take some time, pause in between these, get out that Fort Knox map, and some of these you can even do with the digital one, and I want you to answer some of these. Now, some of these answers are already in your lesson from earlier. I already gave you the map sheet number and the contour interval, but I want you to practice actually taking that map out and getting this information. So find the map sheet number, find the contour interval, Find what your GM angle is in degrees, which you can find on that declination diagram. It'll tell you what that degree is. I want you to find what adjoining sheet is directly south of this map sheet. And then you need to figure out if you're going to convert a grid azimuth to a magnetic azimuth, will you add or subtract the GM angle? Now, the GM angle you're going to find right here in your declination diagram. And where it tells you what that GM angle is, it's also going to tell you verbatim, it's going to write it out. It says to convert grid azimuth to magnetic azimuth, either add or subtract the GM angle. It'll tell you which one to do. So I want you to pause the video here, pull out that Fort Knox map, and see if you can write down or find the answers to these questions. All right, now that you're back, hopefully you actually went through and did that exercise because there's a couple more here. For this next one, what I want you to do, if you have that Fort Knox map, I want you to look at it and see if you can find these things. So they're kind of all over. You're going to have to plot a little bit with a 6-digit grid, or in certain grid squares. You're going to look for things in those grid squares. And I want you to plot with a protractor, if you have one, plot what the 6-digit grid coordinate is. Now, if you don't have a map, you don't have a protractor, skip this part, but still talk to your cadre members and see if you can get a hold of one. Come back to this and do the reps. Find the practice, find the time to practice these and figure these out. Now, if you do have that map and that protractor, I want you to look at these ones here. So you're going to look for the large building that's above the Flaherty ES in grid square Echo Golf 8189. And when you find that, you're going to put your protractor down and I want you to plot and figure out what is that 6-digit grid coordinate. So get it down to 81 blank, 89 blank. So find those missing 2 numbers. Then do it again with the pond in grid square Echo Golf 8191. So you're going to go find 8191, that grid square, look for the pond, take your protractor, and figure out if it's 81 blank and 91 blank. What are those blank numbers? And lastly, you're going to look for that intersection in grid square Foxtrot Golf 0381, excuse me. And then when you find that, you're going to bring that down at that intersection, you're going to plot it again, and you're going to find 03 blank, 81 blank. So again, if you have that stuff, go ahead and pause the video here. If you don't, go find a cadre member and get this practice in. All right, now for practical exercise part 3, we're going to go a little bit deeper here. So now we're going to try to identify these terrain features that you're going to find on your map. So with this, you're going to be plotting some 8-digit grid coordinates, and don't get frustrated. It takes time. It takes time to plot 8-digit grids, and it's going to take even more time to start learning how to identify the terrain features. So this should take you a little bit of time, and don't worry about that. The more time you take, the more reps you get in, the more practice you have, the easier this is going to be when you're given your first lane strip at a land nav course. So go through all of these here. There are 5 different grid coordinates, 8-digit grids that I want you to plot on your Fort Knox map with your protractor, and then go back through and see if you can identify what those terrain features are. Now, I'm not going to give the answers on this slide deck because the answers are available to your cadre members. I'm using the exact same practical exercises that they have within their own curriculum, so they can walk you through this as well. But write them down and then go see if you can confirm whether you got them right. All right, so hopefully you're able to work through those practical exercises, at least the first one for sure, because you can still use the digital map for those. If you weren't able to get through them, again, go back, get that in, get more practice. The more practice, the more confident you're going to feel when you're actually out there being evaluated on a land nav course. So hopefully now by the end of this, you have figured out how to identify that marginal information, those topographic symbols, and all those colors on a military map. Remember those common sense colors of black, red, brown, blue, green. What do all those mean? And then hopefully you can identify and classify with a list of those 5 major, 3 minor, and 2 supplemental features on a military map. Remember your 5 major, you can use Hidden Valley Ranch salad dressing. With your 3 minor, you've got those draws, spurs, and cliffs. And your 2 supplemental features, those are always man-made, those are cuts and fills. And then at the end of this, hopefully you're able to get a little bit more confident in learning how to locate grid coordinates on a map and then do a little bit of plotting of those grid coordinates on your own. I can't emphasize enough, if you have questions on these, please reach out to your own primary instructor or advisor. Maybe find a high-speed MS3 or MS4 that could walk you through this. Find another classmate to practice with and get those questions answered, because this is just one of those things that you have to learn how to do in the Army. You have to learn how to do in ROTC because you're going to practice a lot and you're going to go on a lot of land navigation courses throughout your ROTC career. So good luck with this. Please reach out in the comments if you have any questions, and I'll see you on the next lesson.